ACT's R&D focus is the innovation, but we are not just do new concept, we also try to push the concept to the real solution that can be tested in the real operational conditions. We are heavily involved in defense, aerospace, energy, medical equipment, data center areas, and we constantly working with people who are interested in something new and looking for the solution not currently existing in the market. We work closely with our customer, and we know that the speed is an important factor for the customers. And one big advantage for the ACT is we have a very strong prototyping capability, so we can move from concept to prototype very fast. And also we have very strong production team, and we can be the supplier for the customer.
At ACT, our core values are innovation, teamwork, and customer care. Research and development leads the way with the innovation, and that innovation is the key to being able to make that teamwork happen and making sure we've got the best technical solution. There's a lot of new emerging technologies, both the space industry as well as NASA, and our research and development team has been leading the way, developing these technologies over the last 10 to 15 years, and now there's an opportunity to be able to apply those and bring those to life and see them in action.
We have been working on two-phase thermal management technologies for over a decade. We have been fielding them in defense and aerospace industry, like cooling laser guns or cooling high-power electronics for defense equipment. ACT is one of the pioneers in developing high-temperature heat pipes. So there's a lot of interest from the nuclear community for heat pipes. There's also interest for high-temperature thermal storage applications using heat pipes. There's also interest for other space applications using high-temperature heat pipes. We are always innovating to come up with new concepts to enable cooling technologies for these missions. So we have a wide portfolio of ideas and concepts to serve those missions.
The rollout purge unit is a novel environmental control unit that we're making for NASA that's going to cool the payload of the Artemis rocket during rollout. So they take the rocket from the vehicle assembly building where it's being built out to the launch pad, and we get to cool the payload while that's happening. The rollout purge unit is going into a coastal environment, so we have a lot of special hardware and coatings and equipment that can withstand that environment. We're also cooling a payload that's 400 feet in the air, so we have a lot of specialized equipment to get the cool air all the way to the top of the rocket. The rollout purge unit is about 10 times the capacity and about 7 times the size of our typical environmental control units. So we're able to adapt to specific customer needs to meet the demands of NASA in this project.
We have an impressive portfolio of innovations in various temperature ranges. Europa probe, it's one of my favorite technologies we developed here at Advanced Cooling Technologies. Europa, the satellite of Jupiter, may harbor life under the 50 kilometer to 100 kilometer ice crust. We were tasked to come up with a concept to passively perforate that ice through melting using radioisotopes and two-phase systems that work passively. And the probe was also supposed to be autonomous. We just ended a phase 2 with NASA SBIR program, and it was a successful project where we proved that the perforation of ice can be done effectively only with thermal fluids. There is no other heat transfer mechanism.
A lot of our diversified technologies expand beyond thermal management. So we work on exciting things with non-thermal plasmas, super adiabatic combustion, radiation shielding. With our plasmas, we've done a lot of surface functionalization, which allows for oxide removal, a lot of organic passivation. With our plasmas as well, the ability to increase the bond strength between silicon wafers. As we work on other types of coatings with our plasmas and our hot wire assisted atomic layer deposition reactors, we can form several different nanometer thin layers for industries involved in optics and anti-corrosion. The ability to expand outside of the thermal work really adds to the technical capabilities that we have.
We have a very good commercialization record. We also have several ongoing innovation that we see a very promising path that will move to next generation satellite, nuclear power application, data center cooling, application in oil and gas area, in medical sterilization. So we feel a lot of technology innovation here has very promising paths.